Alright, so we finished all the rest, so let's just finish these last 6. So now we're dealing with story problems, which we're still dealing with law of sines and cosines. Now we're just doing a picture, so it's easy to draw a picture. It says Lighthouse B is 8 miles east of Lighthouse A. Okay, so we'll call this B, A, that's 8. And drawing the pictures helps a lot. A boat leaves A and sails 6 miles. At this time it is sighted from B. Okay. If the bearing of the boat from Lighthouse B is 71 degrees, how far from Lighthouse B is the boat? Round your answer to the nearest. Okay. So, the idea here is we're going to have to try to figure out what this length is. Okay. Now, we have a connection here, so we could use the law of sines to get like this angle, and then this angle, and then that side. But I think here this would work for cosine, because we have the angle, the side opposite it. So I'd go 6 squared equals 8 squared, and we'll call this little a, we don't know what that is, plus a squared minus 2 times 8 times a times cosine of, and this might actually not work very well, because we have 2 variables. And even though we can get that, it's going to be hard to separate. So yeah, we definitely don't want to do that. So I take that back. That's why it wouldn't work to do it that way. So, okay, so we start with law of sines. And we'll need to go with that one. We'll call that C. So the sine of C over 8 equals the sine of 71 degrees over 6 times by 8 times by 8. We get sine of C equals sine of 71 over 6 times 8. Take the inverse sine of that whole thing, and we'll get what angle A is. Okay, so again, we use our calculator. So inverse sine of 71 degrees over 6 times 8 gives us an undefined answer, which tells me we set up our problem wrong. Because apparently, we're just not going to get it right on this one, are we? So I wonder if they meant that this was 71 degrees. Maybe that's what they meant. Okay, so then it would be to find angle B, it would be over 6 equals sine of 71 over 8. So we times by 6, so we just flip-flop the 6 and the 8. And that should work. Yeah, that gives us angle B equals 45.16. We'll just say 45 degrees. So angle B is 45 degrees, which, if I go 45 plus 71, that's 116, subtract it from 1. Apparently I turned that off. I don't know at what point I turned it off. So we found angle B. From angle B I went 45 plus 71, subtracted from 180, got angle A of 64. Then it's opposite the side we want, so we times by sine of 64, times that whole thing, and we got 7.6. Apparently I need to double check to make sure I'm recording. Somehow I bumped the button. Okay, you and a friend hike 1.3 kilometers due west from a campsite. Okay, here's our campsite. We hike 1.3 kilometers. At the same time, 2 other friends hike 1.7 kilometers at a heading of 17 degrees from the campsite. So 17 degrees, 1.7. To the nearest tenth of a kilometer, how apart are the 2 groups? So right here. Here's where the law of cosines would work. Okay? Because we'd go 1.7 squared plus 1.3 squared minus 2 times 1.7 times 1.3 times the cosine of 17 degrees. And we just take the square root of that, and so we just type it into our calculator. So square root of 1.7 squared plus 1.3 squared minus 2 times 1.7 times 1.3 times the cosine of 17 degrees. And we end up with 0.59. Okay, so about 0.6 miles or kilometers. Okay, so that one was a little easier. Alright, now let's try 27. An air traffic controller is tracking a plane 2.3 miles due north of a radar tower. So here's our radar tower. It's 2.3 miles north of that. A second plane is located 3.6 miles from the tower at a heading of 72 degrees southwest. To the nearest tenth of a mile, how far apart are the two planes? So to me, this is the same setup, 72 degrees right here. Here's plane 1, here's plane 2. We know that this is 3.6, same setup. 2.3 squared plus 3.6 squared minus 2 times 2.3 times 3.6 times cosine of 72 degrees. Take the square root of both sides, and to make life easy, we just type it into our calculator. And we get 3.62, so 3.6 miles. Okay, 28. A 25-foot water slide has a 10.8-foot ladder, which meets the slide at 100. So, water slide is 25 feet, ladder 10.8, meets at a 100-degree angle. To the nearest tenth, what is the distance between the end of the slide? So here to here. Okay, same setup we've just been doing, huh? So I just set it up just like this, still using the law of cosines here, because we're looking for that opposite side, which makes it easier. Because then we just take the square root, and we type it into a calculator, and we end up with 28.9 feet. All right, and the last one here, last two I should say. A leaning wall is inclined at 4 degrees from vertical. At a distance of 25 feet from the top of the wall, the angle of elevation to the top is 34 degrees. Find the height of the wall to the nearest tenth of a foot. So, I'm assuming angle of elevation to the top would be here 34 degrees, and this would be 25. And we want to find this, so we'd use law of sines. So the side length over sine of 34 would equal our side length over the sine of 4. So we times by the sine of 34 on both sides, type that into our calculator, and we get the length of the wall. So 25 divided by over sine of 4 degrees times the sine of 34. And we get 200.4 feet. Alright, last one. The player waiting to receive a kickoff stands at the 7-yard line, point A. So there's the 7-yard line. This is point A. As the ball is being kicked 61 yards up the field, so that's 61, and that's my beautiful football. The kicked ball travels 69 yards at an angle of 10 degrees. So 10 degrees, travels 69. To the right of the receiver, point B, I'm assuming that's point B. Still on the field, we'll extend our field. Find the distance the receiver runs to catch the ball. So what's this distance? Okay, so again, this is a cosine. Okay, because we're looking for this, so I go question mark squared equals these two sides. 69 squared plus 61 squared minus 2 times 69 times 61 times the cosine of 10 degrees. Okay, take the square root of that, type it into our calculator. And we get 13.85, so 13.9 feet, yards, to get the ball. All right, there we go. We are done with that one, so you should be good to go on this portion of the benchmark.